All right, so 1 through 4. They're already in what's called standard form. So standard, before you name a polynomial, you need to put it in standard form, meaning you need it to go in descending order in terms of its exponent. So highest exponent first, and then it goes down as it goes. And then the second thing that needs to be true is you need to combine the like terms. Anybody remember from last week what makes something a like term?
If it has the same x with the same exponent.
Same x, same exponent, right? All of that's already here for you. You didn't have to do any work, okay? This is just simply naming it. So you name a polynomial based on two things. Its degree and its number of terms. So the degree is the highest exponent. So for number 1, the highest exponent is 3. So this is a degree 3. And then the number of terms, you would just like count. So there's 1, 2, 3, 4 terms being separated by plus and minus, okay? So each of those things are associated with one of those names in the top. At this point, you might not have them memorized, but by the end of the week, I need you to at least know what they mean. Not necessarily memorize them, because like I said, there's going to be a word bank, okay? So you don't have to memorize the words. You just have to know what each of them mean. So which of those words up there is a third degree? Cubic. Okay, so this is a degree 3. So cubic. And then what about 4 terms? Which one's that? Polynomial. This one's like 4 or more terms. And this one is a 3 degree. All right, so I'm putting those two words together, and I get a cubic polynomial. All right, again, it's already in standard form. You don't have to do that. You just have to name the degree and number of terms. All right, so the highest exponent in number 2 is 2, and there are 1, 2, 3 terms. So which word up here is a degree 2? It's obviously not cubic. Quadratic. So quadratic is a degree 2. And what about 3 terms? Andrew? Trinomial. So I'm going to put those two words together, and I'm going to call this a quadratic trinomial. What degree is this one? Because I don't see an exponent. What number is the degree? You're right, it's the first. It's a first. If it has an x, then it has a degree. Okay, so this is degree 1. And you're right, Nate, when you say linear. So this is a first degree. All right, and then there are 1, 2 terms, which is a binomial. So I'm going to put those two things together, a linear binomial. All right, and then the last one doesn't have an x. If it doesn't have an x, we call that a degree 0, and there's only 1 term. So a degree 0 is a constant, and 1 term is a monomial. So this last one is called a constant monomial. These words are not married to each other, meaning like I could have a constant. No, I can only have a constant monomial. I can have a linear monomial. I can have a quadratic binomial. So they don't stay together. Does that make sense? Like you can mix and match the words. This is just this particular example. So you have a quiz this week, and section 1 of your quiz is going to look exactly like that. It may or may not be in standard form, though. All of these were. You might have to combine like terms first and then name them. Do you get what I mean? But there's a section where there's a word bank, and you're naming them. So while you don't have to have the words memorized, you have to know what all 8 of those words mean. We okay with that part? All right, then the other thing we did last week was we talked about combining like terms with addition and subtraction. So Andrew already told me like terms have to have the same variable and exponent. So for this one, those are both my x squared terms, so I can combine them. And then I've got these both just have an x. And then that negative 10 is kind of on its own. There's no other constant term. There's no other non-variable term. So when I combine like terms, I keep the variable and the exponent the same. The x squared part stays the same. And I add the numbers in front. So I would be doing 8 plus 1. So that's going to be a 9x squared. We okay with that? What would I get when I combine my purple terms? That one's tricky. I often have kids want to tell me that's 0. It's not 0. It's negative 12. Negative 6 and negative 6 together, okay? A negative and a positive would make 0, but this would make a negative 12. So just be careful with that one. And then minus 10. Okay, this one doesn't say name them, but it's a quadratic trinomial. It's not a bad thing to practice that. Now, just like last unit, when there are variables involved in the problem, you can still check your answer. You just can't do it in the home screen of the calculator. So if I wanted to check this answer, I would go to the y equals screen of the calculator, and you can see in y1, I put the original question, and in y2, I put my answer. And if this is correct, when I go to my table, all of the values will match. If you made the mistake of thinking that the negative 6 and the negative 6 is 0, and you didn't have this term at all, and you went to check your answer, I'm hoping you'd see you're wrong. See how like this is negative 13, negative 1, 2, 26, they don't match. That's telling me something's not right in my answer. We okay with that? All right, so you can check your work for all of these. Let's look at the next one. On Friday, we talked about how if there's a parentheses, the only way to get rid of the parentheses is to multiply, to distribute. And if there's nothing in front of the parenthesis to distribute, what do we put? A 1. So I'm going to put a 1 here. And I'm going to do 1 times 6x to the third. 1 times negative 2x. 1 times 8. And again, there's parentheses here, but there's nothing to distribute, so I'm going to put a 1. 1 times 4x. Now, that's just 4x, but I'm going to need to put something between them. And because it's positive, I'm going to put a plus. And then 1 times negative 9. From here, I'm going to combine like terms if there are any. And I see I've got this negative 2x and 4x. And 8 and negative 9. So I'm going to combine those. Keeping this in standard form, I'm going to start with the highest exponent and work my way down. So even though 6x to the third doesn't have a like term, I'm still going to write it first. All right? And then negative 2 plus 4 is positive 2. I keep the x the same. Positive 8 minus 9 is negative 1. So this would be my final answer for this one. This is a cubic trinomial. You could check it with y1 and y2. I'm not going to do that for time's sake, but you could. We okay with that? All right, next one. There's parentheses. If I want to get rid of the parentheses, I need to distribute, and in this case, there's nothing in front, so I'm distributing a 1. 1 times 5x to the third. 1 times x squared. 1 times negative 6x. And then there's a 1 here, but I'm not really distributing a 1. What am I distributing? For that second set, it's not really just a 1. It's a negative 1. Negative 1 times 3x to the third. Negative 1 times negative 2 is positive 2x to the second. Negative 1 times 2x. Negative 1 times negative 4 is positive 4. Oftentimes I have kids just look at the x cubes and say it's 8x cubed. It's 8x to the third. And just combine like terms right away. You have to distribute first, or you're going to get it wrong. All right, so distribute and then combine. I've got 5x to the third minus 3x to the third. So that's 5 minus 3, which is 2x to the third. I've got x squared and positive 2x squared. So this is like a 1 plus 2, so 3x squared. I've got negative 6x and negative 2x. Negative 6 minus 2 is negative 8x. And then it looks like I just have the plus 4 on the end on its own. This is a cubic polynomial. Does anybody have questions on that one? Y1 and Y2 is a great way to check your answer. You can check your answer for your quiz this week for 90% of the questions. The only part of the test that you can't check is the names. The calculator isn't going to tell you if it's a cubic polynomial. You need to know that. But it will tell you if your cubic polynomial's right. Okay, so use it. Check your work. All right, last one. I'm distributing because I've got parentheses. The first set of parentheses, I'm just distributing a 1. 1 times 8x squared, 1 times 5x, and 1 times negative 10. The second set of parentheses, I'm distributing a negative 1. Negative 1 times 2x squared, negative 1 times 5x, and negative 1 times negative 9. After you do the distributive property, the parentheses are gone. And then you just need to combine the like terms. So I'm going to start with my x squared, which is my highest degree. 8 minus 2 is 6x squared. 5x and negative 5x is 0x. I'm not going to write that. It's not a term. Okay, so you don't need to write 0x. Negative 10 and positive 9 is negative 1. This is a quadratic binomial. At this point, this is what you should know. We okay with that? Summary of last week. All right, today we are going to do multiplication with these things. So I can multiply polynomials. And when we multiply polynomials, we're going to end up having to use the multiplication property of exponents, which should be semi-fresh in our heads because we used it last unit. Okay? So we'll be multiplying when we distribute it, and we'll be multiplying an exponent by another exponent, which is different than adding them. So we'll use the multiplication property of exponents. And we're going to go back and forth between our toolkit and workbook today. All right? So we're going to start toolkit page 2. And there's a section that says part 3, multiplying polynomials. Before we get started, we're going to do a really fast refresh on the multiplication property of exponents because we're going to need to use that today. So if we are doing the multiplication property of exponents, we are multiplying the numbers in front. We are keeping the variables the same, and we are adding the exponents together. You will multiply if you see these two things have a dot between them, or you see these two things have a star between them, or you see parentheses separating them. If this right here was a plus sign, so don't write this. If the problem looked like this instead, with a plus in the middle, you can do nothing. You can only add and subtract x's if they are like terms. Okay, so if that's a plus sign, it changes the problem completely. But if it's a multiplication sign, you can multiply anything you want. All right? So just a quick refresh from our last unit. I'm going to multiply the numbers in front. Negative 3 times 6. I'm going to keep the x the same. And I'm going to add the exponents together. Remember, if something doesn't have an exponent, we put a 1. So I'm going to do 4 plus 1 to get 5. All right? So we're multiplying the numbers in front. 2 times 5 is 10. We're keeping the variable the same, and we're adding the exponents together. Just the math sense that I need you to have is, if that wasn't an x, if it wasn't a times, and it was a plus, you can do nothing. If it was a minus, you can do nothing. You can only do what we're doing on the board right now because it's multiplication. Adding and subtracting polynomials requires like terms. Multiplying does not. All right, last one. Coefficient is a coefficient no matter what's in front of it. So I'm going to do 10 times 2 times 5. So I'm going to do 10 times 2, that's 20. 20 times 5 is 100. I don't care that one of them's in front of a y and one of them's in front of an x. It just says multiply coefficients. They're all coefficients. So I've got a 100 here. Keep the base the same. So I'm going to keep the x and the y part of this the same. And I'm going to add the x exponents and then the y exponents separately. So for the x, I'm doing 5 plus 5. And for the y, I'm doing 3 plus 12. That's the multiplication property. It only works because it's multiplication. It will not work if there's a plus or a minus between these. If there's a plus or minus between these, you can only combine like terms. So here's what it looks like in polynomial form. You can use the distributive property to multiply a monomial, a one-term problem, into a polynomial, a multiple-term problem. So here's my monomial, and this is my polynomial, although this is really a trinomial, right? So I'm multiplying a single-term monomial by a three-term trinomial. I'm going to use the distributive property to do that. So I am going to multiply this in. So off to the side, I'm just going to jot. The first problem I'm doing is negative x to the third times 9x to the fourth. All right, the second thing I'm going to do is negative x to the third times negative 2x to the third. And the last distributing I'm going to do is negative x to the third times 7, right? I'm multiplying that in. When I multiply each of those, I'm multiplying the coefficients, keeping the x the same, adding the exponents. There is no exponent here or no x that doesn't have an exponent, so I don't have to put a 1 anywhere, all right? So, for the red terms, multiply the numbers in front. There's like a 1 there. So, negative 1 times 9 is negative 9. Keep the base the same. And I'm adding the exponents on these two things. 3 plus 4 is 7. From the monomial to the middle term, it's negative 1 times negative 2, which is positive 2. Keep the base the same and add the exponents. 3 plus 3 is 6. And then coefficients, negative 1 times 7. Keep the base the same. There's no exponents to add, so I'm just going to keep that one the same. I'm done here. Normally at this point I would, now it becomes a plus minus problem because I only have pluses and minuses. And if I have pluses and minuses, my next step would be combine like terms. But none of these exponents match, so there aren't any like terms. This is a 7th degree, because we don't have a name for something with 7. And it's 1, 2, 3 terms. So this is a 7th degree trinomial. All right, so we are distributing here a monomial, a single term, to a binomial, 1, 2 terms. The first thing I'm going to do is 7x times 6x. And the second thing I'm going to do is 7x times 9. When I do that distributing, I am multiplying coefficients, keeping the base, adding the exponents. Remembering that if I have an x and that x doesn't have an exponent, I've got to put a 1 on that. So 7 times 6 is 42. Keep the base. 1 plus 1 is 2. Add the exponents together. 7 times 9 is 63. Keep the base. There aren't any exponents to add though, so I'm just going to keep that part the same. From here, it becomes an addition problem. And with addition, I'm looking to combine like terms, but there aren't any like terms to combine. This is called a quadratic binomial. All right, for the last one, I'm not going to write out the work on the side. I'm just going to do it, right? Because you don't have to write out those steps. So I'm doing 4x squared times x squared. 4 times 1 is 4. Keep the base. And since I'm multiplying, I'll add the exponents. 2 plus 2 is 4. (4x squared times negative 9x). I'll multiply the coefficients. 4 times negative 9 is negative 36. I'll keep the base, and I'll add the exponents. It's 2 plus 1, right? Because even though that doesn't have an exponent, because it has an x, it's a degree 1. So 2 plus 1 is 3. 4x squared times 3. Well, 4 times 3 is 12. Keep the base. There aren't any exponents to add those, so I'll just keep that as a squared. This is a 4th degree trinomial because there's 3 terms. When you are distributing in, that's multiplication. Multiplying exponents means we add them together, and that's a little confusing because last week we're keeping the variable the same and we're keeping the exponent the same, and now today we're changing it. We change it when it's multiplication, we keep it when it's addition and subtraction. Okay, so you just have to know the difference between those two. So we're going to pause and have you practice some of these. On page 5 of your workbook, you're going to do 25, 26, 27, 28. You're going to distribute in. Don't forget to add exponents of 1. If you're looking at a variable and that variable has no exponent, you're going to write a 1 on that. Name them too. Just get practicing naming them. Have your naming chart out and use that to practice. I'm going to go like 5 minutes, 4 or 5 minutes. All right, so for the first one, if I distribute that 5n in, I'm putting a 1 with it, okay? When I multiply through, I get 15n to the 4th minus 5n to the 3rd plus 40n. What's that first one called? Emma? Very good. 4th degree trinomial. For the next one, the 2b was at the end. I just wrote it in the front. It doesn't matter. It's still outside of a parenthesis, so you're still distributing it in. You'll notice I added 1s to both b's here. so that it becomes 2b squared, 22b. What's that called? Quadratic binomial. I added a 1 for number 27 to the 4y, so it was like 4y to the 1. That way I didn't forget to add it when I added the exponents. This is a 5th degree trinomial. And for the last one, I added a 1 to the 6x to the first and to the 7x to the first. So I didn't forget to add that in when I did the multiplication. This is a 4th degree binomial. All of the problems we just did were distributing a monomial, single term. So what do you think we're going to do next? What's it called when you do 2 terms? So we're going to distribute, instead of distributing 1 term, we're going to distribute 2 terms. It's called a binomial. So you're going to learn how to distribute 2 terms in. It's a little harder, but not much. Distributing a binomial is going to involve everything we just did, but in addition to that, it's going to have like terms. So we're going to also have to do what we did last week too. It's more of a combination of what we did today and what we did last week. Whereas this is just 2 separate things. Like this concept has no connection to what we did last week. It was just multiplying. The next one will be multiplying and then adding, so it'll bring everything together. All right? So we're going to head back to the toolkit, and we're going to go, I believe this is still the same page, but maybe not, let's say. Toolkit page 3, okay? When multiplying binomials, 2 terms, so look, 2 terms by 2 terms. When multiplying binomials, use the distributive property. Make sure to distribute the first term in the first binomial to all the terms in the second. Then distribute the next term in the first binomial to all the terms in the second, and so on. Finally, combine like terms. That step's new. We didn't have to combine like terms when we distribute a single term, but when you distribute a double, you'll see there are like terms to distribute. So here's what I'm going to do. I'm going to take the first term in the first binomial, which is 2x, and I'm going to distribute that 2x to everything in the second binomial. Here's what that looks like. 2x times 3x minus 7. Right? That's the first term times everything in the second term. Then I'm going to take the second term and multiply it to everything in the second set. What's that look like? Well, it's the second term times everything in the second set. This is identical to the problems that we were doing on Friday. Remember we said, how do we get rid of the parentheses? We multiply in. Once the parentheses are gone, we combine like terms. So you have to know how to set up that first line. So it's each of the first terms, parenthesis the second term. So this is like the first term times everything in the second set, second term times everything in the second set. I'm not distributing the 2x to the 4. They're in the same set of parentheses. I'm not multiplying them. Are we okay with that so far? All right, now I'm going to do the distributive property, keeping in mind that there are 1s on both of these things. And because I'm multiplying, I'll do the multiplication property of exponents, which means I'll multiply the numbers in front, I'll keep the base, and I'll add those exponents together. I'll multiply the numbers in front, I'll keep the base, and there's no exponents to add, so I'll just keep that as a 14x. All right, and then I'll do 4 times 3. I'll keep the base, and there's nothing to add. And then 4 times negative 7. So make sure to distribute the first term in the first binomial to all the terms in the second. That's what the blue stuff is. Make sure to distribute the next term to all the terms in the second. That's the red term. And then it says finally combine like terms. Do you see any like terms in this group of 4 numbers? What do you say?
Negative 14x and all that.
These are like terms, so I can combine them together. In total, I end up with 6x squared, and then negative 14 and positive 12 is negative 2, and when I combine like terms, I keep the variable the same. Minus 28. This one is a quadratic trinomial. All right, so when I am multiplying a binomial, 2 terms, by a binomial, 2 terms, I'm taking the first number and putting it in parentheses next to the entire second binomial. And then I'm taking the second number in the first one. I'm keeping that the same. And then I'm giving that the parenthesis of the second binomial. I'm writing the second binomial in parentheses twice. The 4x minus 5 got written twice. What's in front of it is the original, the first set of parentheses. It's the same thing every time. The numbers just change. So I'm splitting up the first binomial, or splitting up the first binomial, and then keeping the second one the same. All right? So now I'm going to do my multiplication, keeping in mind that these are ones. So multiply the numbers in front. 4 times 4 is 16. Keep the base. Add the exponents. 1 plus 1 is 2. 4 times negative 5 is negative 20. Keep the base. Add the exponents. There's no exponents to add. It's just a 1. There's nothing to add with that, so I keep it the same. 5 times 4 is 20. Keep the base the same. I would add the exponents if there were exponents to add. 5 times negative 5 is negative 25. I've done all of the distributing that I can do, and now I need to combine like terms. What happens when I go to combine those like terms? What do I get? 0. Negative 20, positive 20 is 0x. I'm not going to write that. This is a quadratic binomial. So here's what I'm doing. I'm taking the first term and I'm giving myself some space and I'm writing the second term. So that's my x minus 3. Each of those terms are getting the 4x minus 5. The only way to get rid of the parentheses that I've got going on right now is to distribute. So I'm going to have to distribute each of these things, keeping in mind that there's ones here. There's like a 1 here. So 1 times 4, keep the base. 1 plus 1, add the exponents. 1 times negative 5, keep the base. There's no exponents to add. 1x times negative 5 is just negative 5x. Negative 3 times 4 is negative 12. Keep the x. There's nothing to add. Negative 3 times negative 15 is positive 15. Once you get rid of the parentheses, you just have to keep your eye out for any like terms. If you have like terms, you need to combine them. What do I get when I combine negative 5x and negative 12x? Negative 17x, right? You don't want to change the x. You want to keep it the same when you're adding and subtracting. Quadratic trinomial. you could totally check your work for this. In y1, x minus 3, 4x minus 5. In y2, 4x squared minus 17x minus 15, right? That's what I thought it was. If this is correct, my table will match. It doesn't. That's not good. What did we miss? Oh, wait, no. 4x squared minus 5x minus 12x. Oh, plus 15. Did I put minus 15? Yeah. See that? It works. Plus 15. Let's try that now. All right, now we're good. I was nervous. I thought it was too long. All right, so you can check your work. Use this. All right? All right, last thing. I just want you to try some before we head out today. So, page 6, number 45, 46, 47, binomial times binomial. If you finish early, try the anchor. It's a little bit harder, but it's not different. It's a binomial times a trinomial. You should be able to apply that knowledge and get that one. Okay, so challenge yourself and give it a shot. I'm going to post the answers in like 4 minutes so that we have enough time to get the answers up there before you head out. I end up with, when I combine like terms, 3x minus 24x. I end up with 4x squared minus 21x minus 18. For the next one, I'll split up the m and the 6. So you can see like the m went here and the 6 went here. Right? The x goes here and the minus 6 goes here. I'm splitting up that first binomial and then I'm repeating the second one. I'll distribute and then I'll combine like terms. And then the last one, I split up the 2x and the 7, and then when I combine like terms, I get 6x squared plus 13x minus 28. What do we think? Are we okay with that? Not bad? If any of you tried the anchor, it's that. Okay. When you were just multiplying it into more terms.
1907. You have a call from.
Right. Yeah. Yep. A19. Huh? A19. Okay, so I just want to remind you guys that you do have a Math Excel due Thursday. You can do all of it. You've got all of the information you need. All right? You should have class time tomorrow and the next day to work on that, but
No, literally.
do it at home too.
Turn it to a week if I just left it at home. So he said, turn it in Monday, and I'm gonna grade them Monday. So I give him it Monday, and now he's gonna come out and do it. Well, it's like the fourth time. This is like the third time he's done this.
Stop teaching, or the parts of the units do you have to
How do I have to
So all of it should be in Canvas. You're doing it's a geometry unit. It's on similarity and congruence, I think. And I think there's a Canvas page that has practice. I don't have any material because I don't teach it, but I can definitely answer questions, I think.
start of this was?
Maybe, if you have them. Okay?
Thank you.
Yep.
And then this. I get 86, but like, we also don't do anything in that, but like, 8.5.